In this problem, we've got a car. I'm going to kind of crudely draw a car right here. And I'll label this as the front end, this is the back end. And we're given a few things. We're given the mass of the car. We're given the length between the tires. I'm going to call that big L. We're also given the length between the front wheel and the distance, and the point of the car's center of gravity, which I'm going to call little l. And you want to find the force from the ground on each set of tires, the two front tires and the two back tires. First off, I'm going to make a little force diagram here, where here's the little car, and we've got the weight acting down on it, of course, mg, capital M, my bad. And counteracting its gravity is a normal force, which is the sum of the forces from all four tires. So this normal force is equal to 2 times the force on each front tire, plus 2 times the force from each back tire. So I'm labeling the force from one front tire as F sub F, and the force from one of the two back tires as F sub B. We'll come back to this equation later. But for right now, when we're looking at the forces on individual sets of tires, I'm going to look at this in terms of torque. So let's look at the net torque acting about the back set of wheels. That's what I'm just going to choose to do. You could do whatever you want. And it's going to be equal to 0 since the car is not moving. It's in static equilibrium. And I'm going to define a counterclockwise rotation to be a positive rotation. And this back wheel here is the axis we're looking at for this equation. Now there are two sources of torque here. There's a positive torque acting from the ground on the car through its front wheels, and there is a negative torque acting downwards. It's the force of gravity on the car from its center of gravity. For the positive component there, that's going to be the torque from the ground on the front set of wheels. So that's 2, because there are two tires, times the force on each of the front wheels, times L. That's the lever arm because it's the distance between the two sets of wheels, from our axis to those front wheels. As for the negative component from the weight, that's going to be big M times G. This is from the weight of the car. And this lever arm will be, the distance from the axis, the back wheels, to this center of gravity right here. So that's going to be big L minus little l. Big L minus little l. And now let's rewrite this equation to solve for F sub F, because that's the thing we're asked to find in part A. This is equal to 0, so setting these two terms equal to 0, like this, and now we solve for F sub F by dividing both sides of this by 2L. And this is the formula that we end up with. The weight of the car times the distance between the two L's divided by 2 times the big L. If we plug this into our calculator, we find that this force is about equal to 2.77 times 10 to the power of 3 newtons. Now, for finding the force acting on the other set of wheels, we could do this exact same process, and that would work fine, but there's another way we could do this. As I mentioned earlier, we could use a force diagram to find this formula relating the normal force, which is equal to the weight since they're balanced, with both of the forces acting on both sets of tires. What we could do, now that we have one of the forces, is rewrite this equation to solve for the other variable. So if that's mg equals 2 times F sub F plus 2 times F sub B, and we're looking for B, then we can pretty easily algebraically rewrite this to solve for F sub B as mg minus 2 times F sub F, all divided by 2. And this is a much simpler formula, an easier formula we could use to find the force acting on the back set of wheels. And if we plug these values into our equation now, we'll find a force of about 3.89 times 10 to the power of 3 newtons. And that is our answer to part B, the force on the back wheels. And that is all for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me make more videos like this. And if you have any questions, please leave a comment down below and I'll do my best to help you out. But that's all for now, and I hope you have a good night. Bye-bye.